Hello everyone. From this tutorial onward, I'd like to transition from 2D geometry to 3D geometry, which although more difficult owing to the third dimension involved, is also the most true to real life, and so, therefore, would be the most useful form of math to apply in real life. There are actually many techniques you can use to break down 3D shapes and get them back into a 2D perspective, which is what I will demonstrate explicitly in each tutorial video. Just as the square is the most simplest 2D shape to analyze, the cube is the most simplest 3D shape to analyze. Geometrically, a cube is a 3D shape where all the faces have equal length and width, as well as right angles at all of their corners. Just as a 2D shape has edges on the outside to define its perimeter, a 3D shape has edges on the outside of each face, and the faces will always meet or join at these edges. In many applications of 3D geometry, such as sewing clothes, you will hear an edge referred to as a seam instead, but it means the same thing. With some creativity, we can see a 3D shape as nothing more than a 2D shape that has been folded up along the edges where all the faces meet. However, attempting to imagine or figure out the 2D representation of a 3D shape is not something that can be predicted with formulas or equations, but rather something that requires spatial reasoning skills and creativity. Because we know a cube is defined as a 3D object where all the faces have equal length and width, it follows that we can break down a cube into 6 squares, where the part that is flattest already, the bottom part, would be the center point of the unfolded pattern, and the 4 sides that constitute the height of the cube would form a plus shape around the center, and the top part would be 2 squares away rather than 1 square away like the rest of the sides. Although this kind of technique seems to be useful only in theory, it can be used A, to demonstrate how the shape was made to begin with, B, visualize the surface area of an object, or C, model the object using computer graphics. We can see, based on this breakdown, that the surface area, or the total area of all the sides of the object, would be 6 times s squared, where s is the side length of one of the squares. There is a more complicated type of area that is exclusive to 3D shapes, and this is called volume, which refers to how much physical space something occupies. If we remember, by the definition of a cube, having an equal length and width on each of its sides, it should come as no surprise that you can imagine the volume being seen as a square on the bottom, a square on the top, with squares stacked in between the bottom and top layers, and the total height of the stack, by definition of the cube having an equal side length on all of its sides, would have to be exactly either the length or width, which are also equal to each other. So we can see the formula for volume would have to be length times width times height, or since they are all equal, length times length times length equals length cubed. Although conventionally you will see the formula as s cubed instead, where s means the side length along one of the edges, just like it does for squares. Now that I've explained how to figure out the surface area and volume of a cube, we can transition to a more sophisticated shape, the rectangular prism, which is the 3D analogy to 2D rectangles. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.